Hello, I'm audible. Hi, good evening, everyone. Hi, good evening, everyone. Hello, I'm audible. Hello, 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 I'm audible. Hello, hello, hi, hello, everyone. Hello, I'm audible. Okay, thank you. Okay, okay. So, welcome, everyone. And again, today I'm in front of you with some new thoughts, and we will take up once again from last topic. Last time, I was helping you to design different types of gates with help of not with the universal gates. Okay, let me summarize you again. Okay, in our first class, if you remember, in our first class, like we have designed basically gates with help of NAND and NOR. Okay, NAND and NOR. Then in the same class, we have designed all gates without, actually this was with shorting. Okay, and then same we have designed without shorting. Okay, so without shorting is something like which is a new things which why I have taught you to do this without shorting, so that you should design anything from your own logic. Okay, it is not like that ki you should go and just copy the same thing which is already designed. Okay, so what happened if you design with the help of without shorting? With help of without shorting, you will develop the logic. Okay, in my first class I mentioned that I am here to develop the logic. Okay, so logic building is very important, right? If you build the logic, interviewer will always happy that I am selecting the guy who is always a logical. Okay, so logical in terms of two things, either see, you can become a logical with the help of concept. Here concept is like a Boolean algebra. Okay, here concept is like a Boolean algebra or truth table, like with K-map, okay, etc. Right? And here a concept, something like if you don't remember, sometime maybe you miss the Boolean algebra concept. Okay, sometimes you forget to how to derive uh, those equations. Okay, with the help of various theorems. Okay, sometime maybe you miss because of lack of practice. So you can develop with help of hit and trial. Okay, so if I'm asking about hit and trial, so if I'm asking about hit and trial is basically where you are playing with the gates. Okay, where you are playing with the gates. So this without shorting is same thing. We are developing our own, we are designing our own gates with the help of NAND and NOR, but without shorting. This is one thing which we have done. Okay, in second class, I am just summarizing it. Okay, in second class, that is a class 2. Okay, we have taken two more gates. Okay, earlier maybe some of you or many of you aware of it that only the universal gates NAND and NOR is used to design all the gates. Okay, why we call those NAND and NOR is a universal gate? Because we can design AND, OR and NOT with help of any NAND or any NOR. That is why we call them as a universal gate. But yes, there are two more logic like single input bubble OR gate and single input bubble AND gate. Okay, so with the help of these two, you can design something like this. Okay, something like this. This is a single input OR gate, and this is single input AND gate. Okay, so if you are new today, at least you please go to the live, please go to the second class, and with the help of these two, I use this one to design AND and NAND, and NAND, and then later on OR and NOR again. Okay, so with the help of this single input bubble OR gate. In the last, we were trying for XOR. Okay, we were trying for XOR and XNOR. I was very happy even just a few minutes back. Okay, one of your one of the candidate student has shared me the, even two of them have shared me the solution. Okay, even I didn't try it in my last class. I will try this today. So he has shared me the solution, and the solution is really good. I really appreciate. Okay, you guys are putting the efforts. Okay, please put the effort so that it will definitely help you when you are going for an interview. Okay, so today I will try this, and we will take up one more thing, that is a black box approach. Okay, so let me see if you have any questions. Okay, no questions. If you have any questions, please write in a comment. I will definitely take up. Okay, so in last class, okay, so in last class, I was designing with the help of single input bubble OR gate. Let's design a XOR. Okay, let's design a XOR. First, we will see the XOR implementation using NAND gate. So XOR, what is XOR? This is your XOR. Okay, the output of XOR is 0 0 0 1 1 0 and 1 1. So when you have two inputs are same, 0 0 and 0 0, we will give it 0, and when you have two inputs are different, we will give a OR. Okay, OR means this, or you can write OR, so it will be output is 1. So this is a basic truth table of OR. So the implementation of XOR with your own NAND gates. Okay, this is the implementation of XOR with the help of NAND gates. Okay, so this is already designed. Okay, this is already designed. Okay, so if you know, this is very good, because at least from here you can start something, correct? So let's try the XOR implementation with help of single input bubble OR gate. Okay, single input bubble OR gate. Again, all those who have gone through the last class, they are aware of it, how we have designed the different gates with help of XOR, with help of OR gate. Okay, so I'm going directly to the solution. Please pardon me if you are not aware of it. If you really want to check, if you have a curiosity, please go and check. Okay. So let's design this same thing. Okay, let's try with one method. Okay, let's take this is A and this is B. Okay, we know that this is A. Okay, this is B, this is A, this is X. Okay, I'm just naming it. Okay, and this is Y or this is Y. Okay, something like this, or you can take this A also and you can take this B also. I'm just summarizing it. Okay, now let's design this. Okay, in my last class, I have explained that whenever we are designing any gates, okay, so we have to think in such a way that what we have to kept where so that we should get some output. Okay, when we are trying this, okay, when we are trying this bubble, okay, this bubble I have kept here also, this bubble I have kept here also, and this bubble I have kept here also. So what is this bubble? Basically this bubble is nothing, it is actually a NOT gate. Okay, this is actually a NOT gate, this. Okay, this is actually a NOT gate. Okay, so whenever you are designing anything, you are trying different option at different place, and when you start putting your values, I basically get some output. Okay, I have received some output. Okay, so that is why I am using this bubble here. Okay, if you want to learn, okay, you please do one thing. Please keep one time bubble here, then you keep one time bubble here, and then bubble here, then bubble here, and then please keep putting the value and see what output you are getting. Okay, this will make you practice. This will make you to like to learn more different things. Maybe some other things you will achieve with the help of putting the different this bubble at different options. Okay, now I have designed this. Basically this is a NAND gate. Okay, this is a NAND gate. How this is a NAND gate? Okay, how this is basically a NAND gate, this one. Okay, how this is a NAND gate? So if I am giving 0 here, this 0 will pass by inverter is 1, and we have already 0 here. 0 and 1 pass by OR gate is 1, and this B is 0. See, B is 0. This 0 is passed by inverter is 1. So 1 plus 1, 1 plus 1 will give you 1. So in NAND gate, when you give 0 0, the output of AND gate is 1. Sorry, the output of AND gate is 0. But what is NAND gate? NAND gate is a invert of your AND gate. So we have proven these things in our last class. Okay, so this is basically your NAND gate. How you are giving 0 and you are getting 1. Okay, so we have proven one thing. Let's prove one more thing. Let's prove one more thing. Let's take 1 1. Okay, 1. This is 1. 1 passed by inverter is 0. Okay, then 0 and 0 will be 0. Okay, and here B is also 1. 1 passed by inverter is 1. So 0 plus 1, 1. So when I am giving 1 1 in AND gate, it's give 1. Okay, and see, I am getting 1 here. Okay, 0 0 0 0 0 1 1 1. Okay, I have made one mistake. Wait. So okay, let's sometime it is so messy that you can't. Okay, A and B, and this is 0. Okay, let's prove 1 1. 1 1. Okay, 1 and 1. So 1 passed by inverter is 0. Okay, and 1 passed by inverter, and here is 0. 0 plus 0 is 0, and 1 passed by inverter is 0. Okay, this inverter, basically this inverter, 0. So 0 plus 0 is 0. So output of NAND gate is 1 per 1 is 0. Okay, so this is also proven. Okay. Again, it is not easy. You have to try with different options. Okay, so basically we have to replace this NAND gate with AND gate. Okay, sorry, this NAND gate with our single input bubble OR gate. So let me try A 0, B. Okay, now this A, okay, this A, okay, and this option and this option. You have basically these two option. Okay, so let's try. This is basically your 0. Okay, then similarly this is NAND. Okay, I have not put anything here. Now this NAND the representation of this option is from here, and now we are going to design the another NAND gate with the help of single input bubble OR gate here. Okay, let's see. 0. So this one, okay. Maybe I may be wrong, okay, but we will prove first, okay, then we will decide. Okay, so yeah, this. Okay, so let's prove. Okay, is this circuit giving the output of XOR or not? Okay, let's try this. Okay, why I am able to make? Because I have practiced it. Okay, so maybe sometime what happened again, while you guys are doing the practice, maybe sometime you will put 0 here, sorry, this bubble here, and then please try, and then, or you can put this bubble here and then try. Okay, so by hit and trial method you will definitely get some output. Okay, so let's see what happened. Okay, so A is 0, B is 0. Okay, A is 0, B is 0. So 0 passed by inverter is 1. So 1 plus 0 is 1. Okay, right. And now B is passed by inverter B is 0, passed by inverter is 1. So 1 plus 1 is 1 here. Okay, similarly this 0 is here. Okay, maybe I have done one mistake here. I have not put this. Okay, so this 0 is passed by inverter. This 0 is passed by inverter or bubble is 1. So 0 plus 1 is 1. Okay, we have to be very sensible while putting this value. Okay, because a single mistake can affect your hard work. Okay, now this 0 is here. Now this 0 is passed by inverter is 1. 0 plus 1 is 1. Okay, now this 1 is passed by inverter is 0. So 1 plus 0 is 1. Okay, similarly this 1 is passed by inverter is 0. So 1 plus 0 is 1. Okay, now this 1 is passed by inverter is 0, and 0 plus 0 is 0. Okay, it means 0 is here. Okay, and then this 1 is coming here. 1 is passed by inverter is 0. So 1 plus 0 is 0. See, finally we got the output 0. So in XOR, when you give 0 0, when you give 0 0, your output is 0. See, when you give 0 0, your output is 0. Okay. Now I will try second one. Okay. Second one means let's try with 0 1 also. Okay. Now I have to erase. Okay. Erase means one by one we will erase. Okay. Basically this is 0. This is bubble. Okay. This bubble. Okay. And this is bubble. Right. Now let's try 0 1. Let's try 0 1. Okay. 0 and 1. Okay. So 0 passed by inverter is 1. 1 plus 0 is 1. B passed by inverter is 1. So 1 will come as the output. Okay. So 1 plus 1 is 1. Okay. Now here 0 passed by inverter is a bubble is 1 and 1 plus 0 is 1. Right. And this 1 is passed by inverter is 0. So 0 plus 0 is 0. Okay. Now this 1 will go here. This 1 is passed by inverter is 0. So 1 plus 0 is 1. And this 1 is passed by bubble or inverter is 0. So 0 plus 0 is 0. Okay. Now what? 1 is here. 1 is passed by inverter is 0. So 0 plus 0 is 0. And 0 is passed by inverter is 1. So 0 plus 1 is 1. See. So at 0 plus 1, you are getting 1. So this is my final output. You can see here. This is my final output. Any questions? Let me see. Okay, sir, please implement NAND using XOR gate. No, gate. Okay, we will take up. Okay, this is one. Okay. Now, let's try the third option. Okay, let's try the third option. 1 0. So let me remove this one by one. Okay, now we have to remove. I have received one question that we will take up later on or in next class, because I have to finish some objective for today. Okay, now let's take 1 0. Okay, 1 0. Right? 1 0. 1 0. 1 is passed by bubble is 0. 0 plus 0 is 0. Okay. 0 is passed by inverter is 1. So output is 1 here. This 1 is passed by inverter is 0. 0 plus 0 is 0 here. This B is 0. B is passed by this bubble is 1. 0 plus 1 is 1. 1 is passed by this bubble. Okay. 1 is passed by this bubble is 0. 0 plus 1 is 1. 1 is passed by this bubble is 0. 0 plus 0 is 0. 0 is passed by this bubble is 1. Okay. And so 1 plus 0 is 1. And this 1 is passed by bubble is 0. So 1 plus 0 is 1. See. So we got our this last one. 1 plus 0 is 1. Okay. So again, our objective is not to teach you the traditional things. Okay. Start thinking like an engineer, because engineers are always think differently. Okay. They have a different approach. They have a different mindset. Okay, they are very disciplined. That is why these things basically is is going to be very easy. Okay, if you think okay, on the first attempt, okay, yaar, I'm not able to solve it, let's give up. So basically, the never give up part is basically has been proven by the engineers only. Okay, ये एक दिन में नहीं आया, हम लोगों ने ट्राई किया एंड देन फाइनली कुछ ना कुछ बनकर आया, उससे कुछ और बन के आया, उससे कुछ और बन के आया, एंड देन फाइनली वी केम टू कंक्लूजन कि हाँ ऐसा भी कुछ होता है. ओके, क्योंकि डिजिटल में बेसिकली व्हेन दिस इज आई ऑलवेज मेंशन दैट कि we always follow the book. Following the book is not a bad thing. Okay, basically book is giving you the is opening the channel for you. Okay, this has been mentioned in book and this is designed by this method, so now it's your turn to try something else. Okay, if you don't try something else, then you can't be look like an engineering graduates. Okay, you have to try something different. Okay, now let's try the fourth option, 1 and 1. Okay, so let me remove this. Okay, now let's try one by one, one for one, 1 and 1. So 1 passed by inverter is 0, 1 passed by inverter is 0. Okay, so this, okay, this actually this 1 is here. The 0 plus 0 is 0, 1 passed by inverter is 0, 0 plus 0 is 0. Okay, 0 is here. Now 1, B is 1, so B is passed by inverter bubble is 0, this 0, 0 is passed by inverter is 1, 0 plus 1 is 1, 0, this 1 is passed, this is 1. Okay, this 1 is passed by bubble is 0, 0, 0 is passed by bubble is 1. So 1 is here, 1 is passed by bubble is 0, 0 plus 0 is 0, and this 1 is passed by bubble is 0. See, 0. So finally you got the fourth output. Okay, that means this is perfectly fine. Maybe what happens sometime, maybe sometime you are able to get two option, but third option is not working. So maybe you have placed this bubble somewhere, maybe you have by mistake, maybe you have placed this bubble here, or maybe you have placed this bubble here. Okay, so the error should come. Okay, the mistake, then only you will come to know, okay, this is my mistake, right? So this is one thing. Okay, I hope this is clear to everyone, right? Now next, now let's take a very important topic. Now whatever I'm going to teach you, this is the third part. This is the third part. First part is your without shorting, second part is your bubble input, NAND bubble input and OR, and third is known as black box approach. Okay, black box. This is going to be a very interesting. Okay, very interesting. बहुत इंटरेस्टिंग है, बहुत मजा आने वाला है, बहुत इंजॉय करोगे अगर आप डिजिटल को वाकई टाइम दोगे. ओके, ब्लैक बॉक्स. बिलीव मी, जिस बच्चे ने भी, जिस कैंडिडेट ने भी ये कर दिया, he or she is 110% is eligible for this VLSI industry. Okay, he or she is 100% eligible for this VLSI industry. Why I am saying, again, let me fix one thing. There are two things. One is concept, theory, method, formula, everything, right? And one is no method, no formula, nothing. And then also you have proven. That means you are logical. I'm not saying the guy who is using the method and then solving it, he or she is wrong. No, it is not like that. But maybe in some time, maybe he forgets some equation, some method, some steps he has missed, then what? He or she will be still confused. Okay, कैसे बनाना है, कैसे बनाना है, वो तो आता ही है आपको, right? That you know very well, that is a part of the book, that you know very well. But what extra skills you have learned, you have uh, developed. Okay, so that is my focus. Again, every time whenever I am taking the class, I will focus on same thing. This is going to implement in digital design, this is going to implement in logic building using the coding Verilog VHDL. This is also implement on FPGA side, many things. Okay, so be with me and listen with me. Okay, now this is a black box. Let's take, what is a black box approach? Okay, approach, ROACH, sorry, approach, right? So now suppose that I am taking one interview, right? How I basically judge a candidate? A person came for interview, I will ask, hi, hello, how are you? He will say, yes, sir, I'm fine and doing good. Okay, I will just help him to make some, I will help him to be a comfortable. Okay, कहाँ से आए हो, क्या करते हो, कहाँ पढ़ते हो, right? वगैरह वगैरह, etc. Okay, tell me something about yourself, your parents, your score, what you like most, what you don't like most. Just the objective why this people we are asking, or when you are becoming a senior, why you are asking, just to make the candidates comfortable. If the candidate is comfortable, what I do basically, I basically do one thing. I will take simple, I will take 4 input, 1001, 1101, 1111 and 010. ठीक है? What I will do, I will give this truth table. Okay, and okay, this is out 0, this is out 0, and this is out 1. And I will ask him, okay, I will ask him to put this value here. Okay, let's take this is out 0 and this is out 1. Okay, please be focused here. Okay, let's see what happened. Okay, the interviewer will, like I am an interviewer. Okay, I have prepared this truth table. I randomly designed one circuit and I ask him to give this value and tell me the output. Okay, so A is 1, B is 0, C is 0, D is 1. This is OR gate, this is output is 1. Okay, and this 0 will come here and this 0, this is your NOR gate, so output is 1. Okay, and this 1 is here. Okay, so this is your XNOR, 1 and 1 for 0. Sorry, XNOR means 1 for 1 is 1. Sorry, XNOR. Okay, XNOR is the invert of your XOR, 0. So the output is 0. Okay, similarly, let's put a second value. Okay, let's put a second value. Let's put a second value. 1, B is 1, C is 0, and D is 1. So 1 for 1 is 1, right? This 1 will go here. So 1 and 0, this is your NOR gate. So 1 and 0 means 1 ka ulta 0, right? And this 1 is here. 0 for 1 is XOR में क्या होता है? 0 and 1 is 1. So but this is XNOR, output is 1. So this is 0. Sorry, this is 1 and this is 0. Sorry, this is also 1. Sorry, this is also 1. Okay. Now let's put the third value. Again, the candidate is feeling very happy. Oh, that's great. Sir is just asking me to prove this truth table. Okay, put this value here and sir is asking me how to get the output. Maybe he want to check internally what he's thinking. Oh, maybe he want to check my basic, that I know the gates or not. I'm also very happy that yeah, that particular guy, a person, a student is knowing the output of all gates. Sometimes what happen, even my student or some other student, they forget the output of 9 gates. Okay, happened. This happened. Okay. Now 1111. Okay, 1111. So this is 1, 1, 1 and 1. So 1 and 1 per you will get 1. 1 and 1 per you will get what? 1. Okay. Now this 1 is here. This 1 and 1. Again, this is your NOR. Output is 0. This 0 is here. This is 1. 1 and 0 per you are getting what? Basically 1. So it is output is 0. Right. So this is your third output. And now let's take a fourth one. Okay, let's take a fourth one. 0 0 1 0. 0 0 1, sorry, 0 0, this 0 0 and 1 0. Okay, so 0 0 you are getting, this time you are getting 0. Okay, this time you are getting 0, and after this 0 is here. So 0 and 1, that means your OR is 0 NOR. Okay, now this 0 is here. Okay, so 0 and 0 you are getting 1. Okay, so your output is 0 and 1. Okay, so this is your output. Okay, now see the twist. Now you have a twist. Okay, now what I will do here, okay, this is your A, this is your B, this is your C, this is your D, and you have two output, out 0 and out 1. Okay, आपके पास इनपुट था, आपके पास आउटपुट था, गेट था, and then you have put the value, both input, all the input one by one in one circuit, right? And you realize the output. Okay, you have given this, you got this output, you have given this, you got this output, you have given this, you got this output, you have given this, you got this output. Okay, now here is the twist. Twist is, okay, the twist is, now you have to design, okay, you have to design your own circuit, okay, without, okay, please try to understand, there are some conditions, okay, there are some condition, without K-map, okay, K-map nahi use karna hai, you don't have to use anything, okay, without K-map, without any Boolean algebra, okay, okay, you are not going to use like this, okay, A dot B, जो भी आप use करते हो, okay, you are not going to use such thing, right? No POS, no SOP, nothing, okay, just directly you have to design the circuit in such a way that a one common circuit in such a way that whenever I am giving this input, I am getting this output on same circuit. Whenever I am giving this input and on same circuit, I am getting this output as well as the previous output also with the previous input. Okay, मतलब फिर से बता रहा हूँ, एक ऐसा सर्किट बनाना है जिसपे आप पहला सीक्वेंस दोगे तो ये आउटपुट आएगा, उसी सर्किट पे यू विल गिव दिस सीक्वेंस, यू विल गेट दिस आउटपुट ऑल्सो, राइट। और पहला भी आएगा, फिर आप थर्ड पे आओ, okay, on third you will give this input and you will get this output 0 1 as well as the second and first also, and when you are giving the fourth input, okay, fourth sequence on the same circuit, you are getting the output this also, this also, this also and this also, okay। सारे आउटपुट आपको चाहिए एक ही कॉमन सर्किट पर, सारे आउटपुट चाहिए आपको एक ही कॉमन सर्किट पर, okay। So there is no method, I am telling you, there is no fixed method, there is no fixed hit and trial, there is no fixed logic for this, okay। What is required here? Only two things, one is patience and one is time. You have to give a time, okay, and it is really going to be a very hectic, okay। 95% candidates give up because sir क्या हो रहा है, सर मैंने ये बनाया, ये अचीव कर लिया, सर मैंने ये बनाया, ये अचीव कर लिया, बट सर जब मैंने इसको बनाया तो ये डिस्टर्ब हो गया, और जब मैंने इसको सही किया तो सर ये डिस्टर्ब हो गया, ठीक है, एंड नाउ आई एम गिविंग अप बिकॉज सर 2 दिन लगा दिए मैंने, 3 days लगा दिए मैंने। यस, दिस इज व्हाट एक्चुअली आई वांट। I don't care about 2 days, 3 days, 4 days, 5 days, whatever. If you are a first year, second year, third year, fourth year students, okay, please understand this is not a exam where you are going to pass the exam with the numbers, okay। Number is only required for just for shortlisting, okay। Many of you are asking me, sir, what is the CGPA is required in this company? CGPA is yes required, you have to maintain that, but what happened if you score 10 out of 10 or 9.5 or 9.6 and if you don't know the making the logic? Tell me one thing very honestly, is CGPA is going to help you? No। so CGPA का भूत छोड़ो, लॉजिकल बनो, ठीक है। तेरा फोकस, आपका फोकस लॉजिकल बनने में है, ना कि CGPA आ जाएगा, बिकॉज यू गाइस आर वर्किंग हफ्ता भर पहले और 1 month पहले, राइट, राइट, वो आ जाएगा, okay। now there are 4 methods to, there are 4 way you have to design। first, mix gate, okay, mix gate, use any gates, okay, use NAND, NOR, AND, OR, XOR, XNOR, buffer, inverter, किसी से भी बनाओ, I don't care, okay। first, second, use only NAND gate, third, use only NOR gate, fourth, NAND or NOR, ठीक है, and fifth, again mixed plus bubble, single input bubble बनाओ, ठीक है। so what happened here, I basically take the interview, I basically call the candidates, okay, I ask him, okay, this is the input, this is the circuit, put the value, give me the output, okay, and then I erase the circuit and now I will ask him, good, and I will give him 5 option. He came at 10 a.m., 10:30 a.m. or whatever, 11 a.m. Okay, whenever I took the interview in my R&D company, basically I call the candidates in the morning. I gave him this problem and I went for my work, ठीक है। 1 घंटे में बने, 2 घंटे में बने, 3 घंटे में बने, whatever, whenever you have a full day up to 5 or 6 p.m. okay, बनाओ and offer letter ले जाओ। then offer letter means then this I will pass his or her profile to the next level, okay, but my recommendation is please take him because इस बंदे ने बना दिया है, okay। so अभी क्या करोगे इसमें आप, okay, if this is your input and if this is you need to get this output, then you start using the gates, मैं आपको एक थोड़ा सा हिंट देता हूं कैसे बनोगे आप। जैसे ये आपका A, बी सी डी है, ठीक है, 1 0 0 1 1 1 0 0. I am again taking any random input. Okay, right, out 0, out 0 and out 1, 0 1, anything I am taking 1 0 1 1 and 0 1. Okay, I ask you to start designing with any number of gates. Okay, तो आप मिक्स गेट में आप देखोगे आपका आउटपुट क्या आ रहा है, आउट 0 में 0 आ रहा है, और 0 कब आ रहा है, 1 कब आ रहा है, 1 कब आ रहा है. यू स्टार्ट मैपिंग इट, ठीक है, कि out 0 you are getting 0 whenever the output is 0. That means you have to use somewhere AND gate in this. Okay, here you have to use somewhere OR gate. Okay, here also you used to somewhere OR gate, and here you have to use somewhere NAND gate. Okay, so इस तरह से आप थोड़ा सा सोचना शुरू करोगे कि जो आपका फाइनल आउटपुट, जो आपका फाइनल गेट होगा, जो आपका फाइनल गेट होगा, फाइनल गेट, ठीक है, इनपुट के बाद आपके कुछ और गेट्स होंगे, एक सीरीज, ठीक है, फिर एक दूसरा लाइन आएगा, फिर तीसरा लाइन आएगा, वॉट एवर, राइट. सपोज ये कोई गेट है, आई विल नॉट गिव द सोल्यूशन. ओके, ये कोई गेट है, ये कोई गेट है, ओके, एंड दिस इज योर गेट, राइट. सो यू हैव टू थिंक इन सच अ वे कि जो मेरा फाइनल आउटपुट आ रहा है, ओके, यहां पर फॉर एग्जाम्पल मैं अभी फर्स्ट सीक्वेंस बना रहा हूं, तो दिस शुड बी एंड. ओके, तो यू हैव टू स्टार्ट थिंकिंग एंड यू हैव टू स्टार्ट डिजाइनिंग, यू हैव टू स्टार्ट विद सम गेट्स, ठीक है. गेट को पुट करना शुरू करो और इनपुट डालना शुरू करो, आगे उसके कोई और गेट लगाओ, उसके आगे कोई और गेट लगाओ, एंड देन क्या होगा, आप एक अचीव कर लोगे 100%. फिर आप दूसरे पे जाओगे, दूसरे पे जाने के लिए यू विल रिप्लेस सम गेट्स, बट इन सच अ वे कि पहला वाला इफेक्ट ना हो, ठीक है, दूसरा वाला इफेक्ट ना हो. ओके, सो माय गाइस, मैं इसके बारे में आपको ज्यादा नहीं बता सकता, बट दिस इज समथिंग यूनिक विच आई कैन क्लेम, ठीक है. दिस इज समथिंग फ्रॉम माई माइंड विच आई केम इन माई माइंड एंड आई जनरली प्रेजेंट विद हेल्प ऑफ माई स्टूडेंट्स. ओके, सो अभी क्या होगा, द पर्सन हु केम फॉर इंटरव्यू, उसने एक बना लिया 2 या 3 घंटे में एंड वॉज वेरी हैप्पी एंड वेरी एग्जॉस्टेड. बट अगर एक भी बना लिया, देन इन द सेकेंड टाइम, थर्ड टाइम, फोर्थ टाइम, 1 दिन, 2 दिन, 3 दिन में ही बेसिकली विल डिजाइन ऑल द थिंग्स. सो आई होप दिस इज क्लियर टू यू. ओके, आपको यहां पर सॉरी, आपको यहां पर कुछ ना कुछ स्टार्ट करना पड़ेगा, बिना स्टार्ट किए आप आगे नहीं बढ़ सकते, ठीक है. अगर मैं बोलूं कि मैं कुछ भी एक ऐसे गेट लिया, ओके, अब देखता हूं, दिस इज ए, दिस इज बी, आई एम गिविंग 1 1. ओके, सो मुझे आउटपुट, फाइनल आउटपुट मेरा 0 चाहिए, राइट, एंड सी एंड डी. सो 1 1 पे क्या मिला, 1 1 1 पे क्या मिला, 1. ओके, देन मैंने इसको 0 दिया, इसको 1 दिया, राइट. तो OR gate and this OR gate. So this 0, this 1, this 0 is 1 1 1, I'm getting 1. Okay, so see, but this is first, this is पहला आपने बनाया, this is first you have designed. Now but when you put the another sequence 1 1 0 0, ठीक है, if you put a sequence of 1 1 0 0 1 1 0 0, what happened? क्या ये आउटपुट आएगा 1 1 0 0 पर? क्या यू विल गेट द आउटपुट 1 0? लेट्स सी, 1 1 0 0 1 1 1, दिस 1 विल कम हियर 1, दिस 1 विल हियर 1 0 पर 1. आपको आउटपुट क्या चाहिए, 1 0, 1 इज हियर, बट या अगेन यू कैन सी, इफ आई एम पुटिंग दिस 0, आई एम गेटिंग 1 only, राइट. तो दैट मीन्स व्हाट, सेकेंड सीक्वेंस के लिए ये सर्किट सही नहीं है, तो आपको इस गेट पर कुछ ना कुछ चेंज करना पड़ेगा कि you have to use some other gates, but while using that gates you have to remember that the first sequence should not be affected. Okay, so after thinking 5, 10, 20 minutes, 30 minutes, you will get some gates. Okay, so your two options will be successfully developed. But when you're going for a third, the challenge will again difficult. Okay, and when you go for fourth, again you have a big challenge. Okay, so this is what from my side. Okay, this is called black box approach. Okay, so you have to design this black box approach with help of gates, NAND, NOR, NAND NOR. Choose anyone. ठीक है, पहले आप कोई एक चूज करो, then please design. Right, now I am going to discuss today what projects we are going to design. Okay, many of you have asked me personally ki sir, with the help of digital what projects we can, with the help of digital what we can design. Okay, so there are two things, one is combination, okay, and one is sequential. With the help of combination, we can design a sign calculator. Okay, now what is sign calculator? Sign calculator is, if you have a plus b, a minus b, a into b, and a divided by b. So you have two input of 4 bit, and whenever you are giving 4 plus 5, okay, when you are giving a is 9 and b is 4, so 9 plus 4, okay, everything in terms of binary, please note, 9 plus 4, 13, 9 minus 4, 5, 9 into 5, 35, 50, sorry, 45, and 9 divided by 5, you know, 1 and 4, that is your remainder is 4, right? Now this is all unsigned. Unsigned means, here unsigned means all are positive. This a and b, the value of the sign of a and b is positive. The sign of a and b is positive. Okay, the sign of a and b is positive. So whenever you are giving simple post, you are getting this output, right? Now this is your mode. Mode means operations. Okay, I will discuss one by one project, not all project in same day. I will discuss one by one project one day. Okay, so today I am discussing sign calculator, right? Now this is very simple, correct? Anyone can help, anyone can design. But again, the problem in designing the multiplier circuit and the circuit of divider. Okay, I am talking about we have to design a complete sign calculator operations. Okay, now suppose that a is positive and b is negative. Suppose that a is positive and b is negative. Then what happened? 9 plus minus 4. So 9 plus minus 4 is 5. Simple mathematics. So whenever I am giving input A is 9 and input B is minus 4, तो मेरा output क्या आएगा? 5. इसका hardware design करना है. We have to design the hardware of this. We have to design the hardware of this. Okay. Then similarly here, 9 minus minus 4. 9 minus minus 4 because मैंने अभी अपने B इनपुट का साइन चेंज कर दिया है. ठीक है, मैंने अपने का साइन चेंज कर दिया. देन व्हाट हैपेंड? 9 जो सिंपल मैथमेटिक्स है, क्या है? सिंपल मैथमेटिक्स बताता है 9 plus 4 13. Okay, so I will give you the demo also in next class. I will give you the demo. I will show you each and everything, right? So we have to design the hardware of this in terms of gates. Okay, now this multiply 9 into minus 4 minus 45. Okay, and 9 divided by 5, that means 5 आपको सिंपल पता है, आप जब डिवाइड करते हो Okay, this will become minus 4. So you have to divide. So overall कहने का मतलब ये है कि you have to design. You are my engineer. Okay, everyone is asking about internship. Sir, will I get internship? Internship is not a hua. Okay, it is not a big thing. It is not a big deal. Right? Internship आप तभी कर पाओगे whenever you know something. If you don't know the something, you can't do the internship. Why? Because every VLSI company or every hardware company, every in such type of companies, right, the resources are not free, they are not available free. Okay, and they don't have time to train you. Okay, they cannot give you the hand holding, right? You have to come up with the basic things plus advance on those things. Like for example, if any company is working on FPGA, you should know how the FPGA is working, what is the internal architecture of FPGA, what is how to control the every components of FPGAs. Okay, by just knowing, by just again knowing the digital, you cannot do the internship any FPGA company. You should know Verilog and VHDL at not basic level. You should know Verilog and VHDL at intermediate level and expert level, right? You should know FSM, task, function, everything. And you have designed 1,000 lines of code in your BTech. If you don't know these things, don't ask for internship, right? If you're asking the internship for embedded, you are not a part of any Arduino or Raspberry Pi group because they are good, but at experience level. They are not good at fresher level. Why? Because Arduino Raspberry Pi is made for prototyping. Okay, experienced people basically design and make something fast. That is the real thing. That is the real help of Arduino Raspberry Pi. Here, what you have to do, you have to take any microcontroller, start learning C, embedded C at good level. You should be very good at optimization. Okay, optimization of writing the code. You should know how to use the registers. You have designed, you have controlled motors, you have controlled ADC, DSC, PWM, everything. Then you expect for an internship. Okay, similarly, internship in PCB design. At least you have designed a 4-layer, 6-layer, 10-layer boards. At least 4 to 6 layers. You know how to make it a schematic. You know how to make the BOM. You know, BOM means not BOM, BOM, bill of materials. Okay, and then routing and etc. Okay, so don't come and ask her, will I get internship? No, you will get internship if you know all these things. Okay, similarly, people are asking, sir, can I get an internship in verification or in DFT or physical design? Yes, you can do, but do you know these things, how the physical design flow is working, how the verification flow is working? So that is why the 4th year is here. 2nd year, 3rd year, brush up करो अपने basics पे, and 4th year को choose your best domain and then go for and ask for the internship. Definitely, people will give you. Okay, so this is the one project which I have discussed today. Okay, now tell me how this is, now what we have to do here. You all are my engineers, you have to design the circuit. Okay, मैंने बहुत बनवा लिए हैं, ठीक है, नॉर्थ में बहुत सारे बच्चे हैं जिन्होंने ये बना चुके हैं. ओके, देखो, you have to give A, this is my A and B. So A and B is my 4-bit. 4-bit matlab I can give the input 9 and 4 in terms of binary 1 0 0 1 and 4 means 0 1 0 0. I have to give only this input. I can't give the decimal number, okay, or hexadecimal or octa. I have to give an input in this option. Okay, then you have mode M0 and M1. This M0 and M1 is this A minus subtraction, division, multiplication and division. So when you are giving 0 0, your addition. When you are giving 0 1, your subtraction. When you are giving 1 0, your multiplication. When you are giving 1 1, that means division. A simple calculator in your phone, a simple calculator in your laptop. Okay, you give A 4, then you give addition, and then you give 5. you will get output. वही डिजाइन करना है. Okay, then you have one sign S0 and S1. So whenever S0 A and B, sorry, A and B, so 0 0, जब आप 0 0 दोगे तो दोनों A और B पॉजिटिव होंगे. I am talking about the sign of my A and B. When you give 0 1, it will be plus minus. When you give 1 0, it will be minus plus. And when you give 1 1, that means both are minus. Okay, both are minus. Okay, so and last you have a clear. Okay, your clear button. So when you give clear 0, all output is 0. Okay, so जो operations मैंने आपको भी यहाँ बताए हैं, you have to perform all operations. So you have to design a circuit. Okay, you have to design a circuit. So what is required here? You required adder of 8-bit. You required subtractor 8-bit. You required multiplier 8-bit. You require divider 8-bit. My dear, this is designing of multiplier and divider circuit. Okay, is one of the project. Okay, ये अपने आप में एक project है. Dividing multiplier and divider का circuit, you have to think like as an engineer. And here the theory and concept will not come. Yes, it is there, but the theory and concept will not come. Here what hit and trial will come. Okay, ये दिया तो ये आया. अब इसको बनाना है with the help of gates. Okay, then 2s complement. Sorry to say, whatever the 2s complement you have learned in your BTech, even myself also, that is not going to help us in designing the circuit. There is a flaw. Okay, I am openly saying in this open platform, there is a flaw. There is no flaw in the 2s complement, but there is a flaw whenever I am using the theoretical 2s complement in designing the hardware, it is not going to work. Okay, so we have to make it universal, right? Then it is required mux, demux and decoder. Aapka combination ready. And in your whole life, when you're going to use this adder, subtractor, multiplier, divider, okay, you are not going to use on paper. My dear, please note, there is a tool. Okay, there is a tool known as ISC schematic. Okay, there is a tool. Okay, ISC schematic from Xilinx. We are using that tool and we are going to design this particular project. Okay, so एक बार आपने ये सब चीजें बना ली, then in whole life you are not going to, in your whole life you are not going to forget it. Okay, whenever you go for any interview, you are going to always remember. You are not going to through the book. Okay, mux क्या होता है, demux क्या होता है. Okay, no, I have designed the mux. It is always in my mind. I know how the 2s complement is working. It is always there in my mind. Okay, so just like for example, if you are riding a bike and if you know some place and you keep going up and down, so you always remember that place after 20 years also. Why? Because you have practically explored that path. Okay, that galia. Okay, if you are from Lucknow or you are from main city, very crowded city, you know the small galian, right? Because you have brought and brought up there. Similarly, same thing is here. If you have designed the 8-bit adder, subtractor, multiplier, divider from your own, you are not going to forget the logic or circuit of that particular component. Okay, so this is the one project we have to design. We have to design the hardware. Okay, मैच खेलते हैं ना, प्रैक्टिस करते हैं, सेम वही है. जॉब लेनी है कोर में तो आपको लॉजिकल बनना पड़ेगा. ओके, सो यहां से मैं दूंगा 9, यहां से मैं दूंगा 4 एंड आई विल मेक इट द ऑप्शन इज 1 0. 1 0 means multiply and I will give the option is 0 1. that means B is negative, right? So you have to design, you have to put a block in such a way that every working block, adder, subtractor, multiplier, decoder, demux, in such a way that आपको यहाँ पर -45 बाइनरी में चाहिए. You need a -45 means I am giving 9, I am giving 4. Okay, then I am giving 1 and 0, that means a multiplication. I am giving 0, 1, that means A is positive and B is negative. Negative, that means 9, sorry, 9 into -4, sorry, -4, sorry, -4 है, तो 36, sorry, this is 36. Okay, so 9 minus 4 minus 36. You want minus 36 here in binary. Okay, so if before closing, I'm going to tell you a big thing. Before closing, if you're not part of any IIT, if you're not part of any big tier 1 college or tier 1 university, you can compete with them. You can be a part of that group, that team, but you have to become a logical. The only difference between you and them is that your processing speed is little bit slower than them. A person who has cleared the IIT because he has attempted and solved the question in 5 seconds, and you have attempted and solved the question in 15 seconds, 20 seconds. Okay, so उसको बढ़ाना है, and year by year ये बढ़ जाएगा, 2 मिनट 4 मिनट हो जाएगा. Okay, but when you are part of the engineering and when you are part of with me, okay, you have to maintain that 15 seconds, 20 seconds so that you can start capturing him. If in any team, any IITians is leading that team, you can start thinking, because I know the IITians सोचते, आप सोच रहे हो वो कर देते हैं. ठीक है, मेरे दोस्त ऐसे ही हैं, मेरे सीनियर्स ऐसे ही हैं. दे, आई एम थिंकिंग दे नो, अच्छा तुम ये सोच रहे हो ये ऐसे होगा. Really, that is why they deserve the IITs. Okay, so this is all from my side. Please, again, honest with yourself. Discipline is very important, and make the schedule. Okay, make this schedule and start learning थोड़ा थोड़ा हर दिन सब कुछ. Okay, don't make it कि यार एक दिन हफ्ते भर ये पढ़ेंगे, 2 हफ्ते भर ये पढ़ेंगे. No, don't do this. Okay, focus on practical. Discipline, schedule, workout करो and discipline पे काम करो. Okay, so अभी आने वाला टाइम बहुत चैलेंजिंग होने वाला है with me. Okay, if you are going to follow with me, I promise you that I will make you the engineer. This is my commitment, my promise. Okay, but you can prove me wrong if you don't work, if you don't invest. I am very happy that 2-3 person are sending me the message personally, sir, I have designed this. I am very happy that how that a person in my batch showing me the output. Now the person in my is not in my batch and sitting somewhere in India or outside India, he is sending me the reply. That means something I am doing. Okay, so this is what I want from maximum people. At least I should get 5-10 message. See, sir, I have designed, please correct it. Okay, so this is my reply to everyone. Please, जो भी मैं दे रहा हूँ, please go and design it, please think it. Okay, so summarize करता हूँ. This is what about project. बहुत सारे projects हैं. Sign calculator है, then you have a algebra का hardware बनाना है, then you have to geometry. You have to design the hardware of the geometry equations. You have to design the hardware of algebraic equations. Income sequential, you have a stopwatch. Okay, you have a digital clock, right? You have a LED blinkers, right? You have a traffic light controller. Okay, and then you can design a FIFO and LIFO also, memory. Okay, करने को बहुत कुछ है, but इच्छा होनी चाहिए. Okay, so that's all. This is all from my side. Thank you very much. Thank you. Be honest, be disciplined. एंड बी फॉलो योर शेड्यूल, वट एवर यू हैव डिसाइडेड उसको करो, क्लोज करने की इच्छा रखो, ओपन करने की इच्छा मत रखो. ओके, सो अगेन थैंक यू वेरी मच. जय हिंद, बाय.